Hello, my name is Beth Dixon, and this is a video series based on Vicki Borlaug's PowerPoint presentation on binomial distribution word problems. And I spent a lot of time in the first video explaining some things and getting started and doing some prep work. And this is part 2 of that video series, and it picks up in the middle of an example. So if it doesn't make sense where we're starting, you probably need to watch part 1 of this video series. Our example has Jeffery likes to practice shooting hoops. He makes 74% of the shots. 8 of Jeffery's practice shots are randomly selected. Find the probability that Jeffery makes at least 6 of these shots. And we have our variables. In part 1, we discussed where those variables come from, but we have N, the number of trials, as 8. Our probability of success is 0.74. Q, our probability of failure, is 0.26. And our X, or the number of successes we can have, range from 0 to 8. We have our chart with our numbers 0 to 8, and since we're looking for at least 6 of these shots to be made, at least means 6 or more shots to be made, so that would be 6, 7, and 8. Since we have I'll take a second to say, if you're still struggling with the phrases at least or at most, I do have a video on those phrases, and watch it. It may help. Let's look at the formula for 6, 7, and 8. Notice that the first part of each formula takes 8 combinations and then either 6, 7, or 8. The 6 matches the 6 here. When we're doing the formula for 6, we have 8, choose 6. The 6 comes from the number of successes we want. Then we have the probability of success, 0.74, raised to the 6th power, the number of successes. Then 0.26, the probability of failure, raised to the number of failures. And actually, this is the same formula that we went over in part 1. And that will give us our answer. And I just clicked and they all filled in. But let me go over the second one. When X changes to 7, notice what changes. The 6 moves to a 7, the 6 moves to the 7, and the 2 reduces to a 1. If I have 7 successes, I now only have 1 failure. 6 plus 2 would give me 8. 7 plus 1 would give me 8. This is the number of successes. This is the number of failures. This is the probability of success. This is the probability of failures. With 8, I have 8, choose 8, because I want all 8 shots made. That's a probability of success, so that's 0.74 raised to the 8. And if I have 8 successes, I have 0 failures. Then you place those in the calculator and you get the decimals, or the probabilities here. Since we're looking for 6 or 7 or 8 as being our X, we would add those probabilities together. And when we add those probabilities together, we get a total of 0.6534. And that will be our answer. Part C asks us to find the probability that Jeffery makes at most 6 of these shots. At most would be 6 or less. Now, 6 or less circles 7 numbers. That leaves uncircled 2 numbers. Which is shorter, the numbers we're looking for or the number of numbers in our complement? Well, the complement would be the shorter list. So it will be easier to use the complement to find our answer. So we will use the formulas that we just covered for 7 and 8. Get our two probabilities. I just blew right past that, but that's okay. We'll get our two probabilities and add those together. But that won't be our answer. That's the answer to the complement. And to find our answer, we will do 1 minus 0.3426 to get the answer of 0.6574. By using the complement rule and the fact that all of the probabilities add up to 1, we obtained our answer without finding the long list of values, especially since we calculated the answers in the previous work. Here are some exercises for you to try. And I'm going to stop and pause the video here, and we'll pick up where I have left off in our next video.